morning. As Eda said, we'll be talking about how to evolve your architecture, looking towards the lens of modernization. A quick disclaimer before we start. I got to tell you that pretty much every single slide could be a talk itself. So bear with me that we can't go into much detail with the time that we have. Modernization is a constant need, and I think we can't deny that. While you are doing something here, you might need to start looking at there. And that's basically because there are a couple drivers behind modernization. That includes market demands, competitive pressure, advancements in technology. And here, I'm not really talking about like Java 6 to Java 21. I'm talking about things that essentially change how we build or how we use software. Mobile applications, cloud computing, and things like that, that you gotta, catch up in a sense. And also, I can't not talk about talent, attraction, and retention. Couple stats. 78% of the enterprises have started their modernization journey after COVID and as a result of COVID in 2019. But many companies out there is still delay to not even to the last responsible moment, but beyond that, which can be a problem, and don't prioritize modernization initiatives, and that can be pretty harmful to the business. Because, you can say, Camilla, modernization, and we're going to see that. It is a lot of effort. It is complicated. It is risky. But I got to tell you that riskier than modernizing is not modernizing. And the consequences of choosing not to modernize are huge. Here, the first one are risks associated with system failure and downtime. But you gotta see that there are many others out there, and including being unattractive as a M&A prospect. So that can harm indeed the business. Tech debt, lack of modernization, can also get you out there in the news, and not as a very good thing, as we could see for SWA a couple years ago when they had a pretty huge meltdown with their booking systems and all that. That is, it damaged their image, but also got them pretty down on their plans in revenue and all that. And still, nowadays, they are facing the consequences of that meltdown, which was basically because of ignoring and putting aside the conversations about tech debt and application modernization as a whole. Cool. I said before, it's not easy, and almost 3/4 of the organizations that goes on the legacy modernization journey fail to complete them. And what does fail mean in this context? It is basically that it's first, people don't track how they are doing towards the modernization, or the business can't realize even the benefits of the modernization. Many times because people just don't know why they are modernizing things, and that can also be a problem. We're going to talk about that later. And not taking a holistic view about modernization can also lead to failure. When you think that it is only about technology, but in fact there is much more around the technology modernization. You got to improve and see as like a whole transformation in the organization, like processes, people, culture, values. So modernizing for the sake of technology, it doesn't really pay off. We're going to be talking about the essential steps for modernization, and I split this between like 5 steps, and it goes from why modernize to how you can measure success. Starting with why modernize, if I ask like many senior developers out there, or developers out there, why you should modernize, they're going to tell me the code is very complex. I don't have confidence to change it. Or, can you believe it? It is a monolithic architecture. Or, it is pretty outdated. We are still working with Java, 8. And we do have a huge cost around maintenance, and the tech debt backlog just grows and grows. Or there is not even tech debt backlog. And I think they are all valid concerns and reasons to why to modernize. But if you really want to have, like, get funding, if you really want to be able to work on a modernization initiative, you gotta need, like, to find out the business needs. Like, you gotta understand what is those things causing to your organization. And let's see an example. The first scenario is a very well consolidated product or a module of a product. It is a monolith application built in Java 6. It is a complex code base. People at that time didn't know about, like, test automation or those kind of things, or they just, like, chose to ignore. But it is a consolidated product that works well. You don't need to change it. Like, there's not really, like, critical bugs in it, nothing like that. And it's seen as, like, commodity. It doesn't, differentiate you or your company anyhow. Like, so why you should look at modernizing this? It works well, leave it there. If it works, that's fine. Like, it doesn't matter if it's like a monolith application or if it's built like in, COBOL even, or, you don't need to change it. You're not going to face the pain. You're not going to feel the pain. But in this scenario, you also have a very complex code base that is very hard to understand and very hard to change. The developers in the team, they don't have confidence to change it. There are not really guardrails in place, so you don't know, like, the side effects of the changes that you're going to make. And one day, your company was, like, #1, top of mind. But, digital native companies appeared, was born, and you've been losing market share over time, right? So those kind of things make you realize, oh, I gotta do something. I gotta catch up and innovate myself. Otherwise, I'm gonna keep losing market share, profit, revenue, so on and so forth. So in this case, you may wanna look at, like, how can I improve this application? How I'm gonna build new features so people can come back to my product, or even, improve the user experience of it, because people might be dropping because the competitor has a better experience. Behind, or not even behind, but in front of the technical challenges of modernization, you gotta look at the business needs, and valid ones in the scenarios that we spoke about are, it's difficult to add new features. The core system it breaks. I got an outage during Black Friday. So my market campaign did really well, but the system didn't handle the load. You are struggling to hire top talent because people just don't want to work in certain technology or even with certain processes. And the users don't want to use the platform anymore. They are dropping and they are using another one. So those are indeed real needs to start and look at modernizing things. Now, how do I know what I should modernize? Sometimes, and I got this earlier in my career, people just tell like, okay, we're going to modernize this, and sometimes they even told me like, you're going to modernize this by doing that. Fine. But not, later, you might be the one looking at and analyzing what needs to be modernized. And when doing this, you can have different perspectives, 3 different perspectives mainly. You're gonna see, and you can modernize the platform, so the infrastructure that it's deployed, for example, you can go from on-prem to cloud, or even like the tech stack, so, programming languages, or the database, the data integration, and those kind of things. You can modernize the product itself. And when I'm talking about product, it means alignment with the product strategy, not the client. In my case, it's client because I'm a consultant, but your business strategy, client needs. Is it still relevant to them? Does it do what it was supposed to be doing? Does it solve their problems? And also, as I mentioned before, the user experience. So sometimes you got to revamp that, do some user research, and understand, what you can do with the technology available or new technology available. The architecture modernization, though, I look at it from 2 different perspectives: the design and the domain. So you can, address tech debt. You can do a domain redesign, or even like a re-architect of the entire system. But you can also look at like remodeling the domain. And that means that you gotta deep dive and understand and discover more about the domain that you are in. And the benefit of it would be evolvability. So it's easier to add new features. As the business changes, the software changes with it. When defining what to modernize, you gotta, understand what are the features that are out there and their purpose, if they fit for purpose. Usually I say don't reverse engineer things, basically because by doing that, you don't know exactly what's being used. And you might spend a lot of time looking at features that users just don't use because it doesn't add value to them. Instead of reverse engineering, look at the usage stats of it. So, how that is being used, how is the flow of the user in the product, and things like that. If you don't have tooling to do that, that's fine. Go and talk to the customers. Go and talk to your clients. Application rationalization, for those who are enterprise architects or have played this role, this is probably more common to them, or they're more aware of this, but it's basically understanding, looking at the inventory of applications that you have in your organization and understanding what are the critical ones, what is the value that it adds, alignment with the business goals. And really, like, is it commodity? Can I just go and buy one out of the shelf tool? Then it's fine, go and buy it. But if it's something that differentiates you, you gotta innovate, then it might be worth like looking at building it and hence modernizing it. Total cost of ownership. basically, the comparison here is how much do I spend to keep the lighters on in this legacy system versus how much value does it bring back to my business? Is it worth? Does it pay off? Cool. Otherwise, you might have a candidate to modernize. And last but not least, what are the technical limitations of the system, of the applications that you have? What is holding you back? Many times the quality attributes of architecture, like performance, scalability, and things like that, are going to give you a pretty good clue or where are the problems and the bottlenecks. You gotta check also like for outdated technology as well as code hotspots. And basically because code hotspots predict bugs. And we're gonna talk more about that later. How can I do that? For the first two ones, Wardley mapping is a pretty good method and exercise that you can run. Please, if you're gonna do it, do it in a very collaborative way that is like much more valuable than, in fact, the artifact that is built from the exercise. Total cost of ownership, basically Excel and sheets out there, but there are tools, especially in the cloud ecosystem, that can give you a pretty good clue about the costs that you have with cloud. And for the technical limitations, let's dive in a little bit more. So looking for technical issues and limitations, I gotta say, assess your architecture. And that is regard scalability, performances, security, the age of technology, as well as try to find hot code hotspots or very hot code hotspots. The first one, which is scalability, means is the system able to handle the increasing volume of data or increasing number of users that you are projecting or that you are getting without degrading performance? If so, cool, then you don't have a limitation over there. You might run load tests, stress tests. Load, you do look at some volume, you run it, see if everything's fine. But if you want to see, okay, how further can I go until it breaks, then you go with stress tests. For performance, it reads well. How well the system responds in the current circumstances. And here we usually look at like response time, latency, resource utilization, CPU, and things like that. So you've got to find out where are the bottlenecks. Is it processing? Is it memory? Networking? And one sensible default tool that we usually use for performance testing nowadays is K6. So it has a pretty good developer experience and command line interface where you can kind of integrate it even in the build pipeline. So you gotta, if performance is really important for you, you gotta check it like every time that you make code changes or changes in the software in general. Security. So you gotta see if you are vulnerable to cyber attacks. Usually, identity, like authentication, authorization, and infrastructure configuration on the cloud, those are like hotspots around security. And tools like Scout Suite and Orca could help with that, could help you spot that. As well as like Sneak, OWASP top 10, and there is like dependency check for that and other toolings that could help you. You gotta see if you are compliant with the rules in your industry, or if you are risking being sued or like to pay a huge amount of money because of not complying with the industry standards. For PCI compliance, we have CDK NAG, and in the autonomous mobility space, there is a new entry. Not really familiar with that. I hope it works because I brought it here. But it is powered by Gen AI, so I thought you would be interested. It's deontic. And to find out if you are compliant with the open source licenses of the libraries and frameworks that you are using in your software supply chain, there are like FOSA and CAST OSS risk control. And the asterisk means that it's also powered by Gen AI. So those are just like new entries in the field. We are still assessing and keeping an eye on it at Thoughtworks. The other thing is the age of technology. If you have outdated technology, you very likely have vulnerabilities. If you have lack of support, either from the community or the vendors, you might face, there is like a security vulnerability there, but there is no security patch being released because there is no support anymore. The other thing that you gotta check for is compatibility with new technologies. So in the project that I work on, we were concerned with, the legacy system uses Hibernate 4, and we were, trying to build new things with Spring 5 and more modern stack. But at some point we couldn't because the legacy technology was not compatible with the new technology that we wanted, and we had to drop and downgrade. We were a little bit frustrated, but that happens. Tools that can help you with that is basically dependency managers, plugins, and for NPM, there is also NPM outdated. I'm just giving you like examples, so you don't go out there thinking that, oh my God, I need to do that all by myself, and I'm gonna like write scripts to find out everything that Camilla said that I should be looking at. Keep in mind that you can leverage existing tools and technologies out there. Code hotspots. This is really a concept that comes from your code as a crime scene. Adam, in the book, he defines the code hotspots as something that is very complex. So, and it can be in even lines of code, even though it's not a really good metric, but complex somehow, because there's even like a study that says that doesn't really matter which complexity metric you are using. They all kind of like give you the same clues when you put together with the version control system data. So it's basically code that is very complex and also changes over time. It's relevant. So if you're touching, it's relevant. If you're touching and it's complex, and you don't have the guardrails in place, you very likely get a bug. So those are code hotspots where you could potentially look at first. So that will give clues where to start and what to modernize. Instead of looking at the static or the snapshot of the analysis or the data, look for trends. Look, for example, like late development, like a year ago till now. That's going to give you a clue, a better clue of how things are progressing, and even like tell you a little bit about how they're going to continue progressing. So you're going to be more spot on what and where you got to change. As I said, hotspots can predict bugs. And tools that help you with that is CodeScene, which is a product of a company funded by the author of the book that I mentioned, but also CodeCity. In toxicity analysis. So how toxic is your code? And this is from a colleague, Eric Durnenberg. who is also a co-author of the Total Stack Radar, and he has this sort of like really high thresholds, which is like, there is really not consensus around like how long is a method. Cool, but if it goes like beyond 30 lines, it is indeed a very long method, and no one can deny it. So that is like going to extremes and looking at like how toxic it is. And the cast imaging is like from the cast family, which is also powered by Gen AI. Cool, we looked at why and what, and now we are gonna move into the, current state analysis. One thing to note is, maybe we want it, but the process is not linear. You gotta do this and come back, and gotta do this and come back. And especially these two, like what and the current state analysis, there is a closed loop between them. When looking at code assessment, usually what I do, and people that work with me, we look at the broad system landscape. We look at like the system boundaries, look for readability, how is it to maintain, and also for the legacy seams. Deep dive in a little bit more, go broad to see the big picture, see how the components interact with each other. Have a look at what are the deployable units that you have and how they interact with each other in runtime. If you find anything that looks like an anti-pattern, like bottlenecks, dependencies, points of failure even, then you gotta zoom in a little bit more and try to find why that is happening. What are the side effects of that? And then you can come back to the what and say, look what I found. Maybe we gotta look at this subsystem first instead of that one. System boundaries, and here it is around mainly modularity, subsystems modularity, the integrity of the layering. So for example, do you have business logic in the UI? Maybe you have a problem. Or, are my subsystems decoupled enough? And last but not least, subdomain alignment. So in this case, it is very related to the domain of the application. So does it respect, here we are talking about like bounded context. We are talking about things that change together, you keep together. Things that don't change together, then you can decouple. Otherwise, you have decoupled stuff that change together, then they are coupled anyways. For readability and maintainability, a good trick, I'd say, is have a look at the shape of the code. It is amazing how it's gonna be like easy to spot very complex code or testing cases when you actually look at a very simple and clean code. And then you can, spot complexity where it's very hard to understand the code. And if I can't read, I can't understand, very likely I'm not gonna be confident to change it. Then if I'm looking at adding new features, I might have a problem here. And legacy seams, they're really helpful to break the whole modernization problem into smaller pieces. So if you're looking at delivering in an incremental and iterative sort of way, which you should, and we're going to talk a little bit more about that, then try to find architectural seams, like how things depend on each other, how the calls from, let's say, the API goes over and over, and what are the pieces of the ecosystem or the subsystems that it touches. The code seams are more related to coupling, like high coupled classes and things like that, and not so coupled as well. So you got to understand a little bit more, like where are the hotspots, and then you might have like an ability to split things, and then you say, okay, I deliver this first, and then I can deliver that independently later. As I said, dependency mapping, and look at task coverage and code quality. Do not look only for task coverage and quality code, because it doesn't give you a very broad view. It is very narrow. You might get into issues if you only look at that. Visualize the architecture, right? I told you, have a broad view. You gotta build that somehow. At least in my bubble, in my bubble, the C4 model is the most used one, the most popular. And if I can give you an advice around tooling, prefer diagram as code tooling. You're gonna version it. It's gonna live together with the code. If you need it, like other stakeholders to see it, because sometimes that is what people say, to not version it together with the code. You can very easily get the diagrams to be plotted like in an HTML and publish it like in any like internal website, Confluence or anything like that. The same applies to ADRs, architectural decision records. Please keep them together with the code, especially related to the code that is introducing the changes regarding that architectural decision record. Anyway, these toolings are the most famous ones, I guess, at least in my bubble. The GraphSys, Mermaid, and Structurizer. And, you know, these two others can help you with generate diagramming from your code and helping you to visualize and explore really like in different levels of detail, the architecture, dependency mapping, and all that kind of stuff. And, you know, the asterisk means powered by Gen AI. I don't know if they work, but they seem promising. Keep an eye on the ThoughtWorks Stack Radar. We gotta tell you if we have good experience with it later. This screenshot here is one of the pages from the C4 model website, and it gives you like a couple choices, so you can kind of like get ideas about toolings that you can use. So in this case, you know, it's gotta be open source. I want like static diagrams, and I want diagram as code, diagram and model as code. So it gives me like this range of tools here. Cool. Why, what, and current state analysis. Halfway through. Before we move on, let's just highlight this. It is an important note, as I said at the beginning. There is a feedback loop. Things are not linear as much as we want it to be. And you gotta prioritize. So the current state analysis is gonna inform like what to modernize, giving you like inputs for prioritization. How complex things are. How many dependencies do I have? And, you know, it increases the risk of change. I can do a change and break really core applications in production. So those things, the feasibility of the modernization or what to tackle first should also be analyzed in order to prioritize where you're going to start. And if I can give you an advice, I usually start with things very simple that adds value to the client and to the organization in general, because I gotta learn how things work, right? Many times you have no clue how things work in the legacy world. So it is continuous learning process. And for the first pieces, we call thin slices. For the first thin slices, go with like simple things that adds value, but let you learn a lot about what you are doing, what you are changing, and then you go with more complex stuff. This is one way to prioritize. I also like to use the effort reward matrix. And it basically looks at like some factors around the modernization, which is going to give you like, the feasibility, the complexity, is it risky or, well, it is risky. Cool. Then how risky it is, I think this is going to give you like a good clue. In this case, we were looking at, minimizing the TCO. So you got to see, okay, what is the safer kind of thing? And this shows like 1, 2, 3, 4, shows the prioritization actually that we made based on those like high, medium, and low complexity, total cost of ownership, business value being delivered, how risky it is, and what are the dependencies. So you can see like the reconciliation business capability has really high, scores really high in the dependencies. So we left it like towards the end because then we learned a lot and then, we can go there with much more confidence. How to modernize? As I said at the beginning, there are very well-known patterns, migration patterns and things like that you can go out there and look, and it's going to be like a talk by itself. We don't have much time here, unfortunately, so I'm going to give you just a couple advices, I'd say. Starting with why I stressed so much the why. The why you are modernizing determines how you're gonna modernize, what you're gonna modernize. You gotta look like, okay, I'm looking at rehost and platform modernization, or am I looking at like product modernization? The technology is fine, but the experience sucks. Or am I looking at like modernizing the design or the domain? And those are strategies. I put a little bit of how to read it because people would be interested in taking pictures and all that. But basically, sunset and maintain, there is no modernization there. You got to see how you optimize things so you don't spend a lot of money keeping the lights on. If you choose like lift and shift, that's basically like taking the application that runs, for example, on-premise, moving it to the cloud. But it can be a good strategy first, but you gotta remodel and reshape it later to take full advantage of the cloud. Like things that were built to run on-prem, very unlikely is gonna run well on the cloud. The legacy encapsulation and legacy policy are basically very technical modernizations. Legacy encapsulation, I like it because it is basically leaving the legacy in a box. You don't change it very much, but you expose their capabilities, you expose their features, very likely with an API. And then that's where you kind of start leveraging platform thinking and thinking, what else can I build on my very core business capabilities? And then you can go broad and innovate. And then you go in different levels of it until you get to the total modernization, which is pretty much like reinventing, reimagining your business capabilities, like your organizations, the role that your organization play in the world, like going wild and changing the business capabilities that it provides, but also the technology, the platform, so on and so forth. But of course, that is like the most expensive one, the riskier one, for sure. when modernizing, and even if you are starting like a greenfield, keep this in mind. I'm not going to be the person who's going to tell you which programming language you're going to use, but I'm going to be the person who cannot emphasize enough the guiding principles and the techniques that you should be using in order to do things right. Evolutionary architecture basically embraces that architecture is going to change. As much as business changes, requirements change, architecture is going to change. It is very kind of, we left in the past the thing that, architecture is something that you do first, it's not going to change, just hand over to the teams and they're going to make it work. This is not going to work. What you're going to do is look at the guardrails, the fitness functions of the architecture, which is basically the quality attributes like performance, scalability, the ELTs usually. Look at how to measure it in an automated way, and that is going to guide how your architecture is going to evolve. So you ensure that things evolve, because they will. The architecture is going to change, cool, but you're going to still keep them fit for purpose. Like, it's going to still be doing what it was supposed to be doing, like in terms of performance, in terms of, even encapsulation, layering, and things like that. And there you can leverage things like architecture unit tests with ArcUnit, for example. Event-driven architecture, basically you build well-decoupled systems with that. It is not easy, but you can do that. DDD, continuous delivery, and everything as code. So everything as code is like extending the idea of like code application and applying engineering practices to everything that you can write as code, like infrastructure, even like architecture, and so on and so forth. The how to modernize, do not keep it only on the technical side. It is not only a technical challenge. It is also looking at like release strategy. It is also looking at like business strategy and what delivers value first. And avoid big bang releases as much as you can. Identify the architectural and the code seams. See how that can help you break the whole thing into smaller pieces. And when you are looking at modernizing, you may not be looking at the entire application or the entire subsystem. Search for thin slice. So that means I can start with one feature with this subsystem and go down the slice. So you get like different layers of that specific feature. You improve it, you see what good looks like, you make it happen, and then you might go to another feature in another subsystem. You don't have to modernize everything in this subsystem or application and then go to the other one if that is not what the business needs, if it's not what adds value to the business or aligned with their priority. How to not modernize? I promised Eder that I would bring like anti-patterns and things like that based on my experience. Default to start from scratch. Yeah, we are gonna start like decoupling everything and event storming, and that's gonna give me the boundaries, like, yeah, it's gonna be very exciting. Cool, but you're gonna fail, especially if you depend on the legacy system. If you might need some level of interoperability between what you are building and the old system. And if you look at like well-consolidated patterns and ways of modernizing, very likely you're gonna need to use the legacy system still. Over-engineering, I cannot emphasize that enough. You build this amazing end-state target architecture and you don't know even like the first step to get there. Don't do that. Have a target architecture, but look at how you can get there in a very feasible way. Do not think that existing technology is going to solve the modernization for you. You got to do something. You got to change things. So be aware of that. Looking at how you measure, I'm going to say two things. Choose the right metrics, because metrics influence how people behave. And culture in this space is really, really important. Assess the metrics over time. Do not do like one time and forget. Like, build the baseline, but assess it over time. And looking at when can I stop? It would be okay to stop if the drivers were stuck, but the drivers of modernization keep moving forward, and you gotta move forward with it. You can't just say, cool, the project's done, fine, I've modernized, but then you need something else. You need to modernize something else. To guide the way, use metrics that let you build the right thing. Oops. Build it right, looking at an engineering excellence perspective, so you can build the right thing. So you look at like the DORA metrics, you look at engineering excellence metrics, and then you can have a look at like how that impacts the business. Success is not one single thing. It is very well rounded. And I brought this here so you can see, and you're probably aware that this space is very, very complex. You cannot look at only like architectural things. That would mean only the dark blue thing here. You gotta see everything else that it allows, or that it impacts, or it's impacted by. Last but not least, bear in mind that modernization is a never-ending journey. It is a journey much more than a final destination. Embrace the process, learn, and enjoy the progress that you make. And finally, happy modernizing. Thank you very much.
We have time for questions. I have one.
I think I overloaded people's mind, and they don't have questions. They need to digest it first.
You did great. Now I have a framework be able to follow to help modernize my architectures, but in my real work, my PM keep asking me every day to push more features, and it's pretty hard for me to convince them the importance of them. What is your piece of advice to me to convince them the importance of this type of efforts?
Yeah, oh my God, yeah, I faced that in many teams, and my advice to people, like developers that were very, very frustrated about that, was look at how the tech that impacts the final user, the customer, the experience. If it hits the product, if it hits the product strategy, it's gonna get prioritized. So if you have, like, for example, a tech that hits performance really hard, response time really hard, and impacts directly how the user experience the product, I'm pretty sure the product manager is gonna say, oh, is that really like the consequence of that? And then you're gonna find a way to start the conversation. I'm not saying that they're gonna deprioritize all the features and start looking at only the tech debts and all that, but you gotta, you have a business way, or you can articulate in a way that the business understands. Like, it is not like, oh, my developers are always gold plating and they can't sleep at night because they didn't refactor. In fact, refactoring, and you do that as part of your job, it is just like one way to move faster. And move faster is exactly what the business wants, right? So.
Thank you, Camilla. It's an amazing talk. If you come from a legacy monolith, and for example, there's one large database, and then you begin a modernization program, and then tens of databases begin to pop up all over the organization, and are maybe not very well managed. What's your experience of that, and what guidance would you have for a company in that situation?
I just faced something similar from what I understood of what you were saying. And we're looking at, modernizing the platform as a whole. And at some point, we were looking at like decoupling the domains and all that, and microservices. Every microservice has got to have their database. But we had a huge data consistency and transaction consistent and cohesion requirement, and we couldn't like apply things like data reconciliation and things like that. And the business at some point said, okay, we might go with microservices, but we are not going to split the database. And everyone was like, what? But this is not microservices. The database is going to be a huge coupling point. All true. But sometimes the business, ultimately it is a business decision, right? So you got to, as a technologist, understand what are the consequences of that. But you cannot go against it. The other thing is put the guardrails in place. So in our case, what we did was we started with a modular monolith that could evolve to a microservices architecture. And because the database was like so messed up, what we started doing was having Arch unit tests in place that could ensure me like that the domains are not gonna get like mixed up, or that let's say the Lowen's domain are not gonna be using something from a non-related table just because it is there, or even like fields in the database that like it is in the wrong table, in the wrong place. So we started like looking at those kind of mechanisms to ensure that the architecture is gonna evolve in the right way. We're not gonna repeat the errors from the past. And then it's going to be, in fact, like easier to extract microservices after that. I wish to be around to see how that's going to evolve.
We are at the top of the hour. Camilla will be here asking
Sure.
any questions. And thank you so much again.
Thank you.